Dr. Smart received the 2021 Frank Freiman Lifetime Achievement Award from the International Cost and Estimating Analysis Association. So please welcome Murray and Christian, and I'll let you guys take the stage.
Okay, thank you. Can anyone hear me okay?
Yes.
So, very good. So today we're going to talk about combining parametric cost risk analysis with earned value management using Bayesian parameter learning. Murray and I have both been just talking. We're very pleased that there's been a lot of discussion of Bayesian methods, and it looks like Bayesian methods are on the upswing. That's a change from around 10 years ago, and I gave a presentation on Bayesian regression at a conference, and a senior executive from OSDK referred to me as a Bayes head. So we're definitely making progress in the right direction. One of the things that a lot of the focus and on the Bayesian talks has been on determining prior values and a lot of the theory. Today, what we're going to talk about is we're going to say we've got some priors and now we've got some evidence. And how are we going to update our priors based on this evidence? And so we start with cost as a prior, and now we have earned value data as our evidence. And how do we update our cost estimate of the final actual cost based on the earned value data? So we're going to start with talking about cost and earned value as some background. We'll talk about viewing those things probabilistically, and then that leads into the Bayesian approach. So we start looking at probability, and the right way to do probability is the Bayesian approach. And the Bayesian approach allows us to combine our cost S curves and earned value data using this mathematical framework. It's pretty basic, it's pretty simple. We're not, it's very practical. We're not breaking new ground in terms of doing anything mathematically, but we are hoping to break some new ground in terms of advancing the state of project management and program acquisition planning. And then we'll close out with some examples. So if we go to the next slide. So the risk curve, innovation drives uncertainty. Uncertainty is very important. It applies to largely applies to innovative projects, which is something that NASA is very focused on. Things like new platforms, custom skyscrapers, developing a new drug. A lot of uncertainty and a lot of risk. And that also applies to Department of Defense as well. I used to work for Missile Defense Agency, and Missile Defense Agency is doing some cutting edge types of things in terms of trying to defend the homeland and the theater from incoming missiles, which is a constantly evolving threat, especially now with hypersonics. So and these are projects that take years to develop, sometimes decades to develop, as we've seen with James Webb Space Telescope. We're currently seeing some of that in the planning for Mars Sample Return and other projects. So we're really focused on this innovation. That's where there's a lot of uncertainty, and that's where NASA and DoD to a large extent operate. Okay, next slide. So the main idea is, if we want to try to reduce uncertainty or try to manage uncertainty, we need to first measure it, and we need to measure it quantitatively. As Lord Kelvin once said, when you can measure what you're talking about, you can express it in numbers, you know something about it. We have no measure of it. We have a very meager and unsatisfactory kind of knowledge. We need to have some quantitative measurement of uncertainty in order to manage it. So we're going to talk about a method to measure this uncertainty as a project proceeds.
Okay, thank you, Christian. We're going to sort of ping pong on this talk, which is always awkward, but we'll see if we can pull this off. So here's the key idea, that particularly in innovative programs, the key program variables, time to complete, cost to complete, performance at completion, are uncertain. They're random variables with probability distributions. And rather than pretend that they're deterministic and you can know in advance, plan your work your plan, come out even, you really have to be measuring the uncertainty and understand and do ongoing intervention in the program to respond to that. So what you do if you, in this kind of thing, the math for dealing with uncertain quantities, random variables, is Bayesian mathematics. And what we're going to do is we're going to apply fairly straightforward, simple Bayesian kind of mathematics to the problem of particularly estimating the estimate of cost to complete and the likelihood of making the budgets. So the idea here is we're trying to connect the cost estimation community with the earned value community so that everything ties together. So we're going to, and as Christian just mentioned, what happens with the initial parametric models and all that, that gives you some sense of your prior estimates, your initial beliefs. Now the project's underway, you're getting actual data on how the costs are accruing and the schedules are accruing. You're going to use that data to update these priors and understand how to, and then particularly if you're going to miss your targets, understand that early and do something about it. So that's the key idea here. Essentially, this is what I just said. As the project begins, you have parametric cost estimates, but the earned data, but as you get into a project itself, you're getting earned value data, percent complete of the actual cost of work performed. How are you going to use that data to estimate how you're going to proceed? So simple view of this is, and again, the thing is that these program variables all have probability distributions. And if your target, say, is 40K for some particular task, and your probability distribution of what is actually of reaching that 40,000, one way to view that is the probability of making your target is the area, the green area of the curve. The red area is the likelihood, is the percent probability you're going to miss your target, and you want to be tracking these probability distributions as you proceed. Okay, so the key idea here, as I said, we've said this before, this is just reviewing a point before we get into the details, is we have prior estimates, we have data, we want to use Bayes' theorem to connect these two. And we're going to do exactly this. So there's two ways to visualize uncertainty. Both matter for program managers. One is what is the review I gave you before, what is the probability of actually hitting the target? The other is, well, how much are you going to miss it by? So we would like to know, for example, if your BAC and whatever units we're working in is 5, budgeted actual cost versus the actual cost at completion. If it was 5 and you come in at say 5.1, that's not too bad. So this percent view tells you what is the probability of at the 80% point, the 50% point, and the 20% point. The other view just tells you whether you're going to make the target and whether how likely it is you're going to make the target and how likely is it you're going to miss the target. So generally the manager wants to know two things. Are they going to make the target? And if they're going to miss it, by how much? Okay. So the key idea here is that the math is, did I miss a chart? Oh, excuse me. Missing chart. This is, okay, I'm going to have to improvise. Sorry, this is awkward. So here's I'm going to just tell you the key idea, and the key idea, there's a white paper that comes out that really explains the math that we're doing. So here, when you get an initial prior estimate of, say, the cost to complete, which that can also be turned into a cost rate. So the idea is at the beginning that what you're saying is by the time you spent all the money, what you expect that the probability of what the money you spent is your prior estimate. So you can convert the prior estimate into essentially a completion rate. And then what you have, this is very awkward not having this chart. Well, that didn't help. So what you have when you get data is you have how much did you spend, how much is your percent complete done, and then by taking the quotient of the two, you get your essentially cost rate. How much is your how much are you spending as a function of the percent completed? Okay, and what you want to know is how is that cost rate evolving as the project continues? Okay, and what we're going to use is the Bayesian analysis. So your EVM data is exactly that. You have the actual costs for work performed. You have the percent complete. You can take that quotient to get the cost rate that you're completing, and that becomes the evidence that you use for updating your prior. And the way we do that is with a Bayesian parameter learning algorithm using a logistic model. And we have a white paper that gets associated with this, that somehow that whole chart that explains all that is missing from this presentation.
On Chase's hidden slide, do you want to see if there's hidden slide?
Is it?
Let's see.
Maybe.
Do you want me to share my screen?
Sure, Christian, if you have it,
Yeah.
No, it's not in this deck.
So
not hidden.
I've got it. I've got it in. Or is it 16? I think it got moved. Is it 16?
No, I'm looking for chart 11.
I
This
think is this
Okay,
isn't this
it's just
the
out of order. So if you want to get back to where you were, just go back.
Oh, okay,
Back.
it's out of order.
I think.
Sorry. How'd that happen? Oh, okay, that's this chart. Okay. So this is the main idea that is explained is captured essentially in this chart. And again, I wasn't going to go through this chart in any detail because this is a practitioner presentation, but we do explain this in the white paper. The key point here is that this algorithm uses exactly the data you collect anyhow for earned value management. But it exploits it in a more modern way using Bayesian analysis to actually estimate. So once you get the cost rate, what you do is you apply that to the percent of work to be done. And then you can predict the future spending that you're going to have. You add that to the actual cost percent already spent, and then you get the what you're going to actually get as an EAC. Okay. There won't be a quiz on any of this, I promise, but that's the math that we apply. So with that, this is fun actually. Okay, so we'll give a couple examples. Okay, so this is an example. I'm going to give two examples, and then we'll talk about where we are in actually implementing this and some future work that can go on. The key idea here, so here's an example where it's sort of the happy day example, everything went according to plan. Okay, so we have only 4 observations in a pure Python style. Observation 0 is the first observation because we implemented this in Python and I was lazy not to fix that in the building of the chart. The money spent is given, the actual cost is given in the next column and then the percent complete. You look at the quotients and you see that the cost rate is very close to the expected, the BAC, which was 5. Okay, so what happens when you do that? Again, we showed these two views. Now, where are we? We're going the wrong way. That's what we're doing. Okay, so then what you get is the two views at what I show here is what happens at 1 observation, what happens at 2 observations, what happens at 3 observations, and the 4th observation. And what you notice is that the probability distribution gets narrower and narrower because as you proceed, you're removing uncertainty because you spent the money and you're on track. Okay, and essentially now the probability of So it may be that you're very close to, you may be, sort of the probability of being slightly over target and being under target are about equal. But the amount that you're over and under target is very narrow. So the 80% point and whatever, as you see here is, in this example, the 80% point is at 5.01, the 50% point is at 5, which is what you would hope. And the 20% points at 4.99. So while your probability of it missing or not missing is about equal, but you're not going to miss by much in this example, which is exactly the information you want to have. So let's look at a more interesting and more realistic example. Okay, this is what I call a recovery example. At first, you're spending too much money to get to the first point. And you know your cost rate isn't 5, it's 5.9 because of the quotient of how much you spent to get to 25% complete. Okay, next time you're still, you slightly better, your next observation, your cost rate has gone down to 5.6. You go, oh my God, this is a real problem. And you do something to figure out how to get yourself back on track. By the way, this is how real project managers work. Hopefully, if they have the data. And suddenly they get the cost rate down to 4.27. Where was I? 4. We'll get there. You know, I used to be a pro at this, but whatever happened. Okay, so we got to 4.27, and then at the last time we're back on track. Now in this case, the results look very different, and you see that at observation 2, we're mostly in the red. So at this point, when you look at this probability distribution with the 2 observations where you're spending too much money, the red chart, you see that the probability of missing the target now has gone up to, what is it, 91%, because you're spending too much money. Okay, and then when you get down to 3 observations, suddenly things after 2 observations, you're in bad shape. By reducing the reducing this cost rate, you put yourself back on track. And now you're looking at a 93% chance of meeting the probability distribution. And then at the end, you have a good narrow, it's not as narrow as the first example, but you're back on track, and your 80% point is 5.06 rather than 5.01 like in the first example. Now we understand these are toy examples, and we'll talk more about how we scale up to real programs in a moment. Okay. Okay, so now this is out of order. So the strengths of these things, of this approach is, one is that the mathematics is, as it's documented, it's very straightforward. It uses, again, Bayesian parameter learning and whatever. We have the white paper for this. But it uses exactly, we're not asking program managers or project managers to do anything they shouldn't be doing anyhow. And in fact, they probably have to track earned value management because it's required by the government in most cases. So we take the earned value data that they already have. We apply it in this framework, and we give them better information than they have, so they actually be more motivated to actually do a good job of program hygiene by actually capturing actually getting value out of the earned value data that they're getting, and get much better estimates than the CPI index, for example. The other thing we're doing is we're combining the either prior information or subjective information, because maybe the initial priors are just best case, worst case, expected case estimates from the subject matter experts who know stuff, and you want to take advantage of what they know as the initial priors, and we update that with the actual data. So it combines subjective and objective measures, or it combines methods like we've learned in the previous two charts of looking at, for bigger tasks, if you want to track up at that level, we take the initial priors from these parametric models and we apply the earned value measures at that point. And that's, again, taking advantage of all the information we have, adding new information, and that's the real spirit of doing Bayesian analysis. Okay, and the other thing, as I showed, like I tried to show in the second example, is you get early warning. You sort of know, but you see the implications. If you know you're spending too much money, you're given very clear feedback that you are, and you're hurting the probability of success, and you have early warning chances of taking interventions early and recovering, doing management interventions to recover and put yourself back on track to either meet the target or replan. Okay, so with all that awkwardness, it's your turn, Christian. Christian?
Oh, just a second, get myself off mute. Can you hear me okay?
Yeah, okay.
Okay, one of the challenges is requiring some cultural change. There's a need for the cost and earned value communities to unite. So if you look at NASA, many times the earned value and the cost estimators report to the same boss. Missile Defense Agency, they used to report to the same boss. Now earned value is part of acquisitions instead of operations. Going the wrong direction, but there needs to be a similar sort of management community, so they're not separately siloed. Need to work together. Cost estimators tend to be, organizations often have a hard time figuring out where cost estimators should be, whether they're engineers or economists, and the answer is yes, sort of all the above. And so sometimes they're in one organization versus another, but there needs to be some coordination between earned value and cost estimates. Cost estimators should use earned value data to update, and then wish earned value estimators and cost estimators work together to forecast EACs. Should be data sharing. It should be a single viewpoint and one source of information. So some work to be done there.
Yes, I guess to reinforce that point, often, maybe it's not so much true as it has been in the past. You see a disconnect between the people managing the project and the people doing the initial estimates. And we're trying to actually break stovepipes and have a common view where people are sharing data across, using data and whatever, and everybody wins with any luck. And
yes, estimators are often used up front and in budget formulation, but when it comes to the program progressing, sometimes cost estimators and cost estimates are not used as much. So
I'll make some final points, and then Christian will estimate. We'll wrap us up. We'll wrap up for us. The examples we showed we understand these are toy examples, and the often a problem with applying Bayesian methods, why haven't they done more in the past, is, and we all sort of know this, is that they're more compute intensive than the simple, just take a ratio and get CPIs or something. Okay. That said, the technology is around today to make these things practical. And it's not too hard. We know how to, and we've scaled these things to big projects. I've done 20,000 lines of WBS items. And the way you do that is by taking some efficient Monte Carlo simulations. And I don't know how many people here ever use the Risky Project tool from Interver, but they're actually adopting this technology, and they're going to actually commercialize this. Hopefully they're going to have an early availability thing at the end of in the fall. So this is the point I'm bringing up here, that this is more than just a theoretical discussion. We're going to bring these tools to market. And by the way, if anyone else wants to adopt them, they don't have an exclusive license, so we can talk. Okay. And by the way, there's nothing patentable here. It's just mathematics. So, but this is the point I want to make is we can scale this to real projects. We're experienced at working with real projects, and we're not just talking about nice mathematics. Oops.
And yeah, one of the nice things about Risky Project is you can, folks at NASA, can be used for joint confidence level analysis.
So I'll wrap it up, Christian.
Okay.
Okay, so we've already made this point that well, we haven't made this point, but this often people will sort of look at the risk and residual risk in a project only at major milestones. But this way you can do it on an ongoing basis. And as you update your actuals for individual WBS items, you get feedback for the whole project as an ongoing basis. Gives you much more continuous transparency into the performance of your project. And we do this for both cost and schedule. What's likely we gave the cost example, same algorithms work for time to complete as cost to complete. That said, there's other things. So we said we're going to do schedules. There's a variety of, well, actually, I'm going to talk about the technical requirements, then Christian, can you talk about the JCL analysis stuff on this chart? Yeah. So we have some ideas for making this better. One of the things is this assumes sort of a linear spending model, but in fact, that's probably not the case. There's often sort of a more elbow curve kind of spending model that we can model instead of nonlinear spending plans. We're going to use fixed and variable costs in the model already. And we're going to start looking, maybe, there was a talk, I think yesterday, on using DAG models, directed acyclic graphs for, we're adding that for dealing with project externalities, very similar to the kind of concerns that were brought up in the previous talk. So we're going to be looking at that as time goes forward. And Christian?
Yes, so this sort of thing can be extended to do joint confidence level analysis updates. So you have a joint confidence level analysis, you have a bivariate analysis of cost and schedule uncertainty at some point using a potentially a parametric model or one of the tools that are commonly used at NASA, such as Primavera or JAX. And now this for which the cost is largely based on parametrics, for example, and there may be some schedule updates. But now you want to make some updates, and you don't want to have to rerun this extensive JCL model of making these schedule updates, but you have some earned value data. So this type of technique can be applied to that. The mathematics still works, a little more complicated, but it's something that we plan on working on. And it's something that can be done to update JCLs without having to, with combining it with earned value data, without going back and just redoing a JCL analysis from scratch. The beauty of this also is it ties to the earned value data. And another thing is to look at the quantitative portfolio management across all directorates. One of the issues with quantitative cost risk analysis is typically don't look at what is the uncertainty at the total portfolio level. What is it across projects? Risk analysis tend to be done for specific projects, but not combined to look at a portfolio view, and that's very important.
Okay, so let's see if I get this right. No, wrong one. Thank you for your time and attention. Any questions? Yes, sir.
Bringing in more of the complex scheduling things, project management issues. What are some of the things or issues that you've seen with trying to make it, like trying to capture that and like bring that to like percent complete when there's dependencies and things like that?
Well, so what happens, dependency, what you end up with to doing that, I mean, we've actually put out we have adapters, we actually built that product, and then that was sold to a company and they didn't implement it. So I'm trying again. Okay, but what you do is you do essentially a dependency informed Monte Carlo simulation to roll up the dependencies and the complex model. So you do, the various end-to-end, So we have those algorithms.
Okay, so that gives you the distributions you're looking for.
Yeah, and it gives you a distribution for the total budget and the total schedule.
And for calculating like the percentage now, like today,
Mhm.
that accounts for as well, I guess.
Yeah. Yeah, so again, it's compute intensive, but it can be done in,
Probably Excel.
well, the thing is, for even a big project, it'll just take like 30 seconds to compute. So it's not immediate, but it's interactive. Yeah, and but in the risky project thing, they're actually building this whole thing, they're re-implementing it in C++ to deal with the performance issues. So it scales. And the other thing is if you cache things right, you don't have to update everything, you just update the things you need to update. So there's caching models. Okay, good, thank you. Any other questions?
I had a quick question. I really like this, by the way. I think it'll finally stop letting people get away with EBM being a check the box exercise.
That's really our hope, make it useful.
Yeah, exactly. But my question is, I wasn't quite clear on what the assumption was for the prior. Is that the original estimate, or is that the spend rate to date? Or
The prior, it can be whatever it is.
okay,
So we can, the whole point is the prior should be a probability distribution.
right?
If it's not a probability distribution, we'll add uncertainty to it to make it a probability distribution. If anyone gives you the prior is exactly $5.321 million, you shouldn't believe it anyhow.
It's a distribution of the spend rate to date. Is that what?
No, so what happens is you get a prior. And well, there's some complications here, but so you have a prior that either comes from the parametric kind of models that Christian and community provide you.
Okay.
Okay, and you can do that at the whole project, and you can do that for the subsystems. Okay, and you can wrap up that way.
Mhm.
Or if you want to go down to the task level, what people do in project management today, like in Primavera and the risky project thing, is they just give a best case, worst case, likely case scenario as a triangular distribution. You turn those into triangular distributions and use that as the examples in the thing for the prior.
Okay.
Okay, and the algorithm doesn't care what actually doesn't care at all as long as you have a PDF probability distribution for a prior, it doesn't care anything more than that. So it's not relying on you giving the prior in a particular kind of distribution. In fact, most of the times you get empirical distributions. Okay, and then
So-
have that. Yes, Chris, I'm sorry.
Oh, it's okay. So Kelly, so I'll just give you something, a little concrete example of how I envision applying it at JPL. I like to apply it in my work at JPL, for example, is we do parametric cost estimates up through critical design review. And then after that point, so we come to, say, system integration review, we don't do a parametric cost estimate for a system integration review. Instead, we look at earned value data and try to use that to forecast. And so what's been done in the past is just looking at heuristics and, for example, taking 1 over CPI or 1 over CPI times SPI, and then using that and looking at cost growth factors. So it's a little bit ad hoc, somewhat heuristics using, some of the earned value data. My vision is, we have a parametric cost risk analysis that was done at CDR using, cost estimating tools, PCEC, NICM, SEER, price, and we have an uncertainty distribution that's developed that way. And now that was done, say, 2 years ago. And now we have 2 years of earned value data. Let's update that cost risk analysis, all that work that was done using the earned value data, and combine the two. So we kind of have the best of both worlds.
Got it. Yeah, I like that.
Thank you.
Yeah.
Well, again, thank you very much for your time, attention.
Thank you.
Yes, thank you.